a laser beam of diameter 1 millimeter has to be converted into beam of 10 millimeter diameter using two convex lenses. As shown, what is the value of focal length f2 of the second lens and the distance at which should be placed from the first lens. There are two lenses. Diameter of incident beam 1 millimeter. We know that parallel beams are meet at focal length. Therefore, this length should be focal length of first lens. It is given as 1.5 centimeters. And to get a parallel beam by the second lens, this length should be focal length of second lens, f2. They have given diameter of this beam is 10 millimeters. Now we can consider this triangle and this one are equiangular triangles. Therefore, we can get the ratio between corresponding sides. 1 millimeter divided by 1.5 centimeters. 1 divided by 1.5 should be equals to 10 millimeters divided by f2. Now we have used these two lengths in millimeters and these two lengths in centimeters. All units are cancelling out. Therefore, we can use without a unit conversion. Then we can find the f2 value 1.5 into 10, 15 centimeters. Then we can find the gap between two lenses. This gap should be 1.5 plus f2. f2 is 15. It is 16.5 centimeters. Then answer is 5. The size of the image of an object placed at distance of 10 centimeters from a convex lens is twice that of object. If the image is erect, the focal length of lens is. There is a convex lens. We know that we can obtain an uninverting image for a convex lens by using an object. The object distance should be less than focal length. If this one is f, this one should be object distance. They have given object distance is 10 centimeters and the size of image is size of the object. It means this image distance should be size of object distance. It should be 20 centimeters. We know that magnification, linear magnification of image formed by convex lens is v divided by u, image distance divided by object distance. Therefore, if the image is twice of object, image distance should be 2 times of object distance. Now we know object distance and image distance. Therefore, we can find the focal length by using the length formula. Then I will use 1 over V minus 1 over U equals 1 over S. 1 over image distance is 20, it is a plus value, minus object distance is 10, it also a plus value. We know that we have to measure all distances from this pole along the main axis, and distances towards light rays should be minus distances opposite to light rays plus. Therefore, these both values are plus. We have to find F value. Then we can simplify it. SCM 20, 20 divided by 21, 1 into 1, 1, minus 20 divided by 10, 2, 2 into 1, 2. Then we can obtain F value minus 20 centimeters. Then answer should be 3. Minus value means it is a convex lens. We know that for a convex lens, we can obtain a minus focal length. Rays from a monochromatic source of light are deviated by an optical element as shown in the figure. This optical element is likely to be. We can obtain given ray diagram by using two prisms like this. Incident rays are parallel. It should be like this. Fourth one is the correct answer. For real images produced by a convex lens, value of object distance and image distance are marked on the U-axis and V-axis respectively. Which of the following best represent the correct pattern? The corresponding UV points are connected by straight lines. We know that when using a convex lens, we can obtain real images when U is greater than F. U means object distance. Object distance should be greater than focal length. For that situation, we know that we can obtain an inverted image like this. Object distance should be greater than focal length. We can obtain an inverted image in this type. Therefore, object distance should be plus and image distance should be minus. We know the shape of UV curve. When the object distance is greater than focal length, we can obtain UV curve like this. Then we can consider given straight line. There is no an image in this part. Therefore, we can obtain fourth one as the correct answer. This one is the VU curve, but they have given the straight line joining corresponding images. the point object O is placed in front of the thin lens as shown in the figure. The refracted path of the incident ray shown is best represented by. I will draw the corresponding ray diagram. We have marked focal length. Object is like this. We can consider it is an object like this. And we can draw the parallel ray. Parallel ray should be past the focal point of convex lens. And then we can consider the ray passing hole. Then an image should be formed in this side, like this. Then I will consider the drawn ray in the diagram. It is like this. It also passing this point. It should be like this after refraction. Then we can get fourth one is the correct answer. A 10 centimeters long pencil is placed at the optical axis of convex lens as shown in the figure. If the length of the image of pencil is also 10 centimeters, the value of the focal length of the lens is. We have to consider images formed by two ends of pencil. I will consider this end of pencil is A, this end is B. I will consider the point A and I will use the length formula. 1 over V minus 1 over U equals 1 over F. We have to find the image distance for the point A. You can obtain object distance is 20. It is the plus value. Focal length is the problem. We have to find the focal length. Then I will find V1 value by using F term, by using this equation. Then we can get 1 over V1 equals 1 over F plus 1 over 20. Then we can simplify it. 20F is the LCM. 20F divided by F 20. 20 into 1 20. Plus 20F divided by 20. 1F. 1F into 1 F. It is 1 over V1. Then I will find V1. 20F divided by 20 plus F. Then I will use same thing for the point B of the pencil. For the point B, 1 over V minus 1 over U equals 1 over F. 1 over image distance V2, object distance from lens to point A is given in the diagram 20 centimeters. Therefore, point B should be 30 centimeters because of length of the pencil is 10 centimeters. 30. 1 over F. Again, I will subject V2 value. 1 over V2 equals 1 over F plus 1 over 30. LCM 30F 30 plus F. Then V2 equals 30F divided by 30 plus F. Now we have to understand, they have given that length of the image is equal to the length of object. Therefore, we can obtain the length of image by subtracting V2 and V1 values. V2 minus V1 is the length of image of the pencil. It should be equal to 10 centimeters because of they have given the image, length of image is equal to the length of object. Then I will substitute these two values. 30F divided by 30 plus F minus 20F divided by 20 plus F should be equal to 10. We can cancel out 1 0 from all terms. Then I will simplify it. We can multiply all terms by LCM of denominators. 3F divided by 30 plus F multiplied by 30 plus F into 20 plus F. It is the LCM. Minus, you know that this part and this part is cancelling. Minus 2F divided by 20 plus F. Same thing, we have to multiply by these two terms. 30 plus F into 20 plus F. It should be equal to 1 times 30 plus F into 20 plus F. Then we can simplify. 3F into 20, 60F plus 3F into F, 3F squared minus 60F minus 2F squared. Then I will remove this bracket. 30 into 20, 600 plus 30F plus 20F plus F squared. We can cancel out 60F and minus 60F. 3F squared minus 2F squared, F squared. We can cancel out that F squared is this term. 20F plus 30F, 50F equals minus 600. Then we can obtain F value minus 12 centimeters. Minus means it is a convex lens and focal value of focal length is 12 centimeters. Then answer is 4. The image I formed by a concave lens of an object pin O mounted on a stand is said to align with the object pin and viewed through a small circular hole H out at the center of the lens. Which of the following figures correctly indicates the view of object pin or an image? There is a concave lens. We know that for a concave lens, always we can obtain a small non-inverted image. Therefore, image through the lens should be small and uninverted like this. And we can see the original object through the hole. It should be larger than image. It should be like this. Then we can obtain first answer is the correct answer. A right candle is placed in front of a convex lens as shown in the figure. if the flame bends towards the direction Y due to wind as shown in the figure, which of the following shown the nature of the image of candle and the flame? We know that object is placed such that object distance is greater than focal length. Therefore, image should be an inverted image, and the flame should be bent opposite to the object in the image. Therefore, answer should be 5. When getting inverted image, we can obtain it is inverted and partially inverted. A convex lens is used to obtain a clear image of an object on a screen. The screen is located 30 centimeters away from the lens and the object is at 20 centimeters from the lens. If the lens is now used to focus the image of a distant tree on the screen, the distance between lens and image of the tree. When using a lens to focus a distant object, distance between image and lens should be focal length. Therefore, we have to find the focal length. For the first condition, they have given screen is located 30 centimeters away from the lens. Therefore, image distance should be 30. And object at 20 centimeters from the lens, it means object distance 20. And it is a convex lens, therefore we can obtain, if the object is in this place, image should be in this place. We have to consider the side. Object distance is a plus value, image distance is a minus value. Then we can use the lens formula. 1 over V minus 1 over U equals 1 over S. Image distance 30, it is a minus value. Object distance 20, it is a plus value. We have to find the focal length. LCM 60 divided by 32, 60 divided by 20, 3. Then we can obtain S value is minus 12 centimeters. Answer should be 1. For the distant object, we can get that light rays are parallel and it should focus to the focal length of lens.